All right, section 5.4 is on the sum and difference identities. So on my identity sheet, down towards the bottom here, we have sum and difference identities, okay? So this is if you have the sine of a sum of two angles, the sine of a difference, cosine of a sum, cosine of a difference, tangent of a sum, tangent of a difference. So all of 5.4 is going to be based on that or anything that we've done before now. And they go through and they do every kind of problem that we've had. So they start with sines, cosines, tangents of angles, okay? So I either have to find a sum or a difference of the angles that I know, okay? So all those angles from chapter 4, sine of 30, 45, 60, 90, so on and so forth. I have to find a sum or a difference that will give me 15, okay? Well, I know the cosine of 60, and I know the cosine of 45. So I could do the cosine of 60 minus 45. That was one example, okay? 45 and 30. I could do the cosine of 45 minus 30. So for this 15, there's more than one way to do this, and you will get the same answer both ways. I'm going to rewrite this as the cosine of 45 minus 30. I'm going to use the cosine of 45 and then 30. Okay, 45 minus 30 is 15. So on your identity sheet, I have the cosine of a difference. So you use the cosine of a difference formula, which is right here. And the sign alternates. So sine, cosine, cosine, sine of the A and the B. Cosine stays the same. Cosine, cosine, sine, sine. And now the difference is, for sine, they are the same. For cosine, they are opposite. So if you say this little cheer in your head, sine, cosine, cosine, sine, cosine, cosine, sine, 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 you can remember the sine of a sum and you can remember the cosine of a sum or difference. It ends up being the same because those are the same and those are also opposite. So one more time. Sine, cosine, cosine, sine, cosine, cosine, sine, sine, sine. And you can remember those formulas without having to use your cheat sheet. And for how many times that you end up using these, it's handy. So, cosine. I do cosine of 45 times cosine of 30 plus, these are opposites, okay, sine of 45 sine of 30. All right. And so cosine of 45 is square root of 2 over 2. Cosine of 30 is the square root of 3 over 2. Sine of 45, square root of 2 over 2. Sine of 30, 1/2. So this gives me the square root of 6 over 4. And this gives me the square root of 2 over 4. And then they're probably going to write the final answer as a single fraction, square root of 6 plus the square root of 2 over 4. And most of the time when you get done, you will have a common denominator already. Okay? So, sine of 5 pi 12ths. 5 pi 12ths, sometimes people have a tougher time with the radians. Okay? If you need to, change radians to degrees. 5 pi 12ths, you remember you take 5 pi over 12 times 180 over pi, and you end up with 75, okay? So 5 pi 12ths, I'm going to write that as the sine of pi, and actually I want pi 6th, 30. I was thinking 30 and I wrote 3. Pi 6th and pi 4ths. Okay? Pi 6th and pi 4ths. This is 75. This is 30. And this is 45. Okay? And because this is an addition problem, it doesn't matter the order that you do them in. Okay? So sine alternates. So sine, cosine, cosine, sine. And this one stays first and this one stays second. Now, if I had flipped those, you're going to get the same thing, okay? So sine of pi sixth, or sine of 30, is 1/2. Cosine of pi fourths is square root of 2 over 2. Cosine of pi sixth, cosine of 30, is square root of 3 over 2. And then sine of pi fourths is square root of 2 over 2. So I end up with, I'm going to run out of room here, square root of 2 over 4 plus square root of 6 over 4, which gives me the same thing, okay? Now remember, 75 and 15 are complementary, okay? And so they should equal the same thing because these are cofunctions. The cosine of 15 and the sine of 75 should give me the same result. So these problems are going to have exact answers. They're not going to have decimal approximations, okay? Example 2 is just kind of a weird story problem, and we're going to skip those. So example 3. Cosine, cosine, sine, sine, sine. Notice this one is this side of the identity, okay? So this is the cosine of a difference because the signs are going to be opposite. So you're going to have the cosine of 7 pi eighths minus 5 pi 24ths, okay? And so if I take 7 pi eighths, this would be the same as 21 pi 24ths. So 21 minus 5 is 16. And 16 pi 24ths is the same as 2 pi thirds. So that puts me in quadrant 2 with a 60-degree reference angle. So my cosine is going to be a, excuse me, 1/2, but I'm in quadrant 2, so it's going to be a negative 1/2. So again, we're reverting back to chapter 4 where we have all of these that we're supposed to have memorized. And then example 3b, tangent's pretty easy to recognize. Tangent formula is just like the sine formula. The signs on the top are the same. The signs on the bottom are like the cosine, and those are opposite. So if it's plus on top, minus on the bottom. If it's tangent of a difference, it's minus on top and plus on the bottom. So we are given a minus on top and a plus on the bottom. So that means it's tangent of a difference. So I'm going to have the tangent of this one minus this one. So I'm going to have the tangent of 6x minus 7x. Well, 6x minus 7x is a negative 1x. But if I go again back to my identity sheet, tangent of negative x is the same as the opposite of tangent of x. So my final answer is going to be negative tangent of x.